Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Noidor Azaiman, EC21102. And my friend Nabil Iman bin Muhammad Yazid, EC21105, will show about simulation of transformer single phase. So here we have open circuit transformers. We use for the nominal power and frequency we use 3000. For nominal power and frequency we use 50 Hz. For the first winding, primary winding we use 330, and the secondary winding we use 215. And at the AC voltage source we use 215 and frequency 50 Hz. Okay, we will start run. Sorry for the compiling, took long time to simulate. Okay, for the voltage open circuit we got 215. For the current at open circuit we got 0.002639. And last, for the power open circuit we got 0.4011 watt. Next we look to the output, which is we have IC, IM, RC, SM, power factor, also theta for the open circuit. For the theta open circuit we got 0.7856, and for the IC we get 0.001866, and for the IM we get 0.001866, the same value. And for the RC and SM it also the same value, that's equal to 1.152 times by 10 power of 5. And last one, for the power factor we got 0.707. Okay, next we go to the short circuit.
Okay, and for the short circuit we use the same parameter for the transformer. For the nominal power we use 3000, and for the frequency we use 50 Hz, and first winding we use 330, and second winding we use 215. And for the AC voltage we use 215 volt, and frequency we use 50 Hz. Now we want to run the program. Okay, for the voltage short circuit we got 215, and the current short circuit we got 1.451 ampere, and power circuit short circuit we got 7.973 watt. Okay, this is output for the short circuit. We have theta short circuit, R equivalent plus X equivalent, and this R equivalent and S equivalent. For the theta short circuit we got 1.545. For the R equivalent plus S equivalent we got 3.787 plus 148.1 J, and this is R equivalent 3.787, and S equivalent we got 148.1. Okay, this is for equivalent circuit for open and short circuit. this circuit we put RC and SM. RC is this value, same as SM. R equivalent 3.802 ohm, S equivalent 148.2 H. Okay, from this curve we find V2. Okay, I run first. Okay, V2 negative 5.497 and IS negative 0.006315, and from that value we can find power factor 0.6589. Okay, for the task 2, we need to investigate the effect of varying certain parameter in the model towards and performance of induction motor. Okay, these are parameters, and this one is the circuit for induction motor. Okay, first we use the voltage 480 divide square root 3, frequency 50 and pole 2, and this is the circuit. Okay, I run this first. Okay, this is a SY plot graph, and this is a electromagnetic torque versus time graph. Okay, the graph is increasing from the 0.8 to 2.5 and drop to 2.8 seconds, and maintain until 4 seconds, and it increasing until 4.2, and it maintain until 9 seconds and drop at 9.2 seconds and maintains. Okay, this is for rotor frequency versus time graph, and this is rotor speed versus time graph. Okay, for the second set we change to the 40 divided by square root 3, and the frequency same, and poles we change to 4. Okay, I run. This is the SY plot graph. Okay, this one the graph is, this one is for electric torque versus time graph. This is rotor frequency versus time graph. Okay, the graph increasing until 0.8 seconds and is maintained and drop little bit until 10 seconds. And this is rotor speed versus time graph. Okay, for the third set we change the poles to 6, and we maintain the voltage 480 divided square root 3, and the frequency we change to 70. I run, and this is SY, and this is SY plot graph, and this one is a electromagnetic torque versus time graph. Okay, the graph we can see is maintained from 0.4 seconds until 4 seconds, and little bit increasing and maintain until 10 seconds. This is rotor frequency versus time graph. It may also maintain until 10 seconds. And this one is rotor speed versus time graph. We can see the graph little bit increasing and drop, and it still maintain until 10 seconds. Okay, that's all from us. Thank you.